Now we're going to be looking at finding trigonometric values that are not on the unit circle. So it's very important to read the directions here and notice that we are not on the unit circle anymore. So since we're not on the unit circle, we draw our right triangle over here for our point x, y. Since we're not on the unit circle, the radius does not equal 1, so we can just call the radius r. And then we still have our x value and our y value on the sides. So now our ratios are going to look just a little bit different because, again, thinking about SOHCAHTOA, but in our previous examples, our hypotenuse has always been 1, so there's been no denominator. Now if we look at sine, the opposite is y over our hypotenuse r. So y over r would be our trig ratio here. Cosine is going to be x over r. And then tangent does stay the same as y over x. Now thinking about those reciprocals, so all we're doing is flipping our fractions r over y, r over x, and then x over y. So again, these are for finding the trig values of a point that is not on the unit circle. So as we just saw, we're looking at finding trig values for points that are not on the unit circle. So let's look at this example. A point on the terminal side of angle theta is given. Find the exact value of the 6 trig functions of theta. So there's no mention of the unit circle here. Exact value is also a giveaway that this is not necessarily a unit circle. So not the unit circle. And because of that, we need to go ahead and verify using the Pythagorean theorem to find what that radius value is going to be. Because if we draw, again, our right triangle here, well, I have my x and y, so -1 and -2, but we don't yet have this radius value. So we need to find that using our Pythagorean theorem. So -1 squared plus -2 squared is going to be that radius squared. So we end up getting 1 plus 4. So the square root of 5 is our radius. So I can write that in here. So now I'm going to be using this, my x being -1 and my y being -2 to help me find these trig values. So we'll go ahead and start with sine of theta, since theta is our angle here. So sine is our y over r, remember our opposite over the hypotenuse, so -2 over the square root of 5. There's going to be a lot of rationalizing the denominator here. And we end up finding -2 square root of 5 over 5 as our sine of theta. Our cosine of theta are adjacent over our hypotenuse, so if theta is right here, my adjacent is -1 over the square root of 5. And again, we need to get that radical out of the denominator. So we end up with -square root of 5 over 5. And then we have tangent theta. So that is our y over x. This one is nice and easy. Simplifies to +2. Now we can think about the other trig functions, so using those reciprocals. So we have cosecant of theta. So if we look at what we got for sine and we flip it, and again we have to multiply. So we're multiplying by 2 square root of 5 over 2 square root of 5. 5 times 2 gives us 10 square root of 5 over, so down here we're going to get negative 4 times 5, which gives us negative 20, which simplifies to negative square root of 5 over 2. So that's our cosecant. Our secant theta is our reciprocal of cosine, so we're flipping negative 5 square root of 5. And again, simplifying this, we end up with negative square root of 5. And then last but not least, cotangent of theta. Instead of y over x, it is x over y, which ends up with 1/2.